Okay, so let's jump into the data here. Ryan had the 100 movies, listed them out, numbered them, used a random number generator to grab 5 movies here, listed here. Each of them has a length and took the average length of 101 minutes. What that says is, based on Ryan's sample of 5 movies, his best estimate of the overall of these 100 movies, the average runtime of those movies is 1 hour 41 minutes, or 101 minutes. That's his best estimate. Now he knows that that's probably not the population mean, so we create this confidence interval to get a rough idea of how close we are. So using the methods with standard error comes up with a low of 85 minutes, high of 117 minutes. So using this method, Ryan's 95% confident that the true population mean of all these movies is somewhere within this range. So is it? Can we be sure? Let's get some more data. So here we have 10 students, all who used random sampling techniques. And what you're looking at here, the box is one standard error above and below the mean. So for example, Stacy, if we went one standard error below her sample mean, it would be just above 100 there. One standard error above would put her right at about 120. The top and the bottom of these whiskers are 2 standard errors away from the sample mean you calculated. So in other words, this is the 95% confidence interval for Stacy, for Ryan, for Amanda, Amy, and so on. Now we can clearly see that they don't all line up, which we would expect, right? We know that when we grab 5 movies, we're going to get a different average time than when one of our classmates grabs 5 movies and averages the length of those 5 movies. So what we would guess is that the true population mean is going to cut somewhere through these confidence intervals, so that probably most of these students have it somewhere within the confidence interval. They have the true population mean. In other words, we would be pretty surprised if the true population mean of those 100 movies was 160 minutes. Notice that Ashley would have still caught it, Jing and Joseph, but 3 out of 10 would be 30% of you would have caught the actual true population mean if it were 160, which it's not. So the question is, what is the true population mean and how many of you caught it? Well, we would expect, doing this method, 95% of you would catch it. Of course, that with 10 students here, we couldn't get 95%, but we would expect 9 or 10. Now, we know that in the short term, random gets a little crazier, so we wouldn't be too surprised if only 8 of you caught it, or maybe even if only 7 of you caught the true population mean in your interval. But certainly, the majority of you should catch it. And just to look at your data from a different perspective here, what this is a histogram of how many of you, so one of the students in the class, said that the sample average for your 5 movies was between 95 and 100. 2 of you said that it was between 100 and 105, and so on, down to the highest person had a sample mean between 130 and 135 minutes. Now what we might guess is, if we have these 10 sample means, we might guess that the true population mean is somewhere in the middle, that these people were a little low, these people were a little high, just based on the 5 movies they happened to choose, and that the true population mean is somewhere here, maybe around 115 minutes. And that's a good way of interpreting it. However, since we only have 10 students, it doesn't give us a lot of confidence in our results. So let's picture if we had a class of over 100 students, let's say 150 students, and we did the same assignment so that each of the 150 students chose 5 movies. Of course, you're going to have some overlap within those samples. Maybe 2 students even get the exact same sample. But they each calculate a sample mean, and then we plot it on a histogram. It would look something like this. So notice here, we're starting to get this bell shape, or this normal distribution shape. We still have some people that are very low and some that have a very high sample mean. In fact, we have some lower lows and higher highs than what we actually had in our class. But we also have a pretty strong cluster here in the middle that's starting to hint at what the true population mean might be. And if we expanded our class size even more to 600, it looks something like this. So keep in mind what this chart is saying. This chart is saying if we have these 600 students, each of who take a sample randomly of size 5 from that list of 100, there would be a little over 75, so maybe 76, 77 students, if we scroll down here, who found a population mean between whatever this is, about maybe 120 and 122 or something in there. But 76 or 77 of those 600 students got a sample average somewhere in that range. So now what we can do is look at the true population mean. So we go over here. I actually listed them all out right here. Found each of these movies. By the way, you can just Google it and you can get a bunch of information about the movie. We'll use the year later on. So calculated it all and just calculated the average of our population, which is 119. So slightly under 2 hours for average movie length of that list. Now let's look how we did in our class with our confidence intervals, knowing now the true population mean, which is, by the way, very valuable information that you very rarely get in statistics. Typically, you go through all your study and you never really know what the true population values are. But in our case, we do. We know that it is a little under 120. So let's follow this line, this 120 line across this chart here. We can see that Stacy, that population time of 119, was within Stacy's 95% confidence interval, right? It was right there. It was not within Ryan's. It may be a little hard to tell that, but Ryan's went up to 117. So he just missed out on the true population mean. It was definitely above Amanda's. And then from then on out, everyone's confidence interval caught it. Now, this doesn't at all mean that Ryan and Amanda did something wrong. This is what we would expect from random. They did everything right, by the way. We would expect this from randomness, that sometimes we're just going to happen to get 5 movies that are shorter or 5 movies that tend to be longer. This is what this inferential statistics is about. This is the type 1, type 2 error that we were talking about last week. So of the 10 students, 8 of them caught the population mean. Now this is nice, but it'd be even nicer to figure out, what if we only take one sample and we want to calculate the chance or the probability that we caught the population mean? Unfortunately, it's impossible. We can never know the probability that we caught the true population mean. So not only do we not know what the population mean is, we don't even know the true probability that we caught it. What we can do is create a null hypothesis. And using that null hypothesis, we can make a distribution, and then we can make a guess. But we'll save that here for the next video. For now, I just want you to get the sense that these confidence intervals that we build around do tend to catch the true population mean, but don't always.